So far, we have used the trigonometric ratios to calculate sines. And for that purpose, we used something like sine 52, and if we push the buttons on the calculator, we will discover that it's equal to 0.788. We need to remember that sine 52 represents a ratio between the opposite and the hypotenuse. So if you consider the 0.788, it's as if the opposite is 0.788 centimeters and the hypotenuse is 1 centimeter, or alternatively that the opposite is 78.8 centimeters and the hypotenuse is 100 centimeters, or anything like that. What we have done so far is that starting from the angle, we got the ratio. Now, what if we have the ratio? How can we go back to the angle? So we are thinking about a reverse process. And we have seen reverse processes. X squared equals 4 is a statement, and if we take the square roots, we cancel the square. We get x equals plus or minus 2. So this way is squaring, and this way is taking the square root, and one cancels the other. So how do we do that with the case of the sine? How do we find the inverse of the sine? Let's say that we have an angle theta whose sine is 0.35. So the ratio between the opposite and the hypotenuse is 0.35 to 1. There is an inverse sign on the calculator that cancels the sign, just like the square root cancels the square. And what we can do is take the sine inverse of both sides. So we have sine inverse of sine theta equals sine inverse of 0.35. Now obviously the sine inverse of sine theta is theta, just like the square root of x squared is x. Sine inverse of sine theta is theta, and we're left with sine inverse of 0.35. Now this is something that we can do on the calculator. You need to press shift and then sine, so you get sine inverse. And as you can see, the line in yellow matches the shift color, which is yellow. And then you say 0.35, and that gives you 20.5 degrees. Now I need to stress that this -1 is not an index. This is not a power. This does not mean 1 over sine. It is just a notation to say that we are inverting the sign. It is not, I repeat, it is not a power, not an index. It does not mean 1 over. So let's see how we can apply that. If we have this right angle triangle with this unknown angle theta, where this side is 4 centimeters long and this side is 9 centimeters long, in this case, as far as theta is concerned, this is the adjacent and the 9 is the hypotenuse. So which ratio connects the adjacent to the hypotenuse? Obviously the cosine. So cosine theta equals the adjacent 4 divided by the hypotenuse 9. And then we take inverse cosine of both sides. We don't need to write the length process here. We can simply move from this statement to theta equals cosine inverse of 4 over 9. And we can check, shift cosine, fraction, 4 over 9, and that equals 63.6 degrees. So this is how we calculate angles. Let's take another example. If this angle is theta, this side is 12, this side is 7.3, and the units are both in meters. They could both be in centimeters, it doesn't matter because it's a ratio. As long as the units are the same, then the ratio is the same. As far as this theta is concerned, the 12 is the opposite and the 7.3 is the adjacent. Obviously we're talking about the tan. So tan theta is 12 over 7.3. Keep this for a moment. Don't look at this. Taking the inverse, theta is 12 over 7, tan inverse of 12 over 7.3, and this equals 58.7. Now be very careful. Some people write this statement, which is correct, and they put equals 58.7 after they've calculated the angle here. Now this is absolutely wrong, because tan theta is a ratio and the 58.7 is the angle theta. Tan theta is not the same as theta. Theta is the measure of the angle, and tan theta is the ratio between its opposite and its adjacent. So putting an equal sign here and saying that this equals 58.7, this is absolutely wrong.